Good morning, good afternoon, or good evening, wherever you are joining us from. Welcome to the Red Space webinar series. Today, we are fortunate enough to have Sarah Padovani joining us. Sarah is a team lead here at Red Space, and in her words, she is obsessed with composition, which is perfect for our webinar topic today, which is write better code through compositional design. Sarah's going to walk us through what good composition is, why it's important, and practical ways to build systems that are easier to understand, test, revise, and evolve. So welcome, Sarah. Before we begin, and I'm going to turn the floor over to you in a second, but I do want to go through a couple of quick housekeeping items. One, I'm going to ask that you save your questions for the end. In the bottom, you will see a Q&A tray. If you don't see the words Q or the letters Q&A there now, click on the More button and you'll be presented with an option for the Q&A tray. Ask your question there. We'll gather them all up. I'll ask them to Sarah at the end. If there is something that is immediate or urgent, I may interrupt Sarah, but the plan is to wait until the end. And then the other piece I was going to just suggest is everyone who is registered for this webinar will get a copy within 48 hours. And just so if you want to watch it again and again and again, because so much value has been provided by Sarah, that is entirely up to you. So, Sarah, without further ado, I will hand the floor to you, and I will keep us moving. I think we are in for a great session today. So the floor is yours.
Awesome. Thank you so much, John. And yes, as John mentioned, composition is probably my longest standing obsession. Anyone who has weathered a round of code review with me knows that it's probably my most favorite word. And so I'm really excited to be diving into it more here today and to share with you how to write better code using composable design. So again, as John mentioned, my name is Sarah Padovani. I'm a web team lead here at Redspace. And throughout my career, I've worked in many different tech stacks and on many different teams, but I always feel most at home here on the web. So before we get started, just a couple of disclaimers I want to get out of the way. So first and foremost, this is not an inheritance versus composition talk. That is a very tired discussion, and I really don't have anything new to add. So instead, we're going to be focusing on talking about designing for composability. Pretty much all of the examples in this slide deck are built in React, and if not React, they're in TypeScript. But my hope is that the concepts themselves are going to be globally applicable. So I'm a pedantic person. I love to talk about definitions. So just off the bat, composition is the act of breaking a complex problem down into smaller problems and composing simple solutions to form a complete solution. So this should probably sound pretty familiar to most of us here today, because I would make the argument that that is all software development. So this means that if you're a software developer, you are already composing, you're already doing it. So you can either do it with intention and care and hopefully do it well, or you can just kind of do it by default and likely be doing it poorly. So how do we do it well? So the very first step in composing software in composition is actually decomposition. We want to split things up based on responsibility. So let's start with a single thing. So this could be an abstract problem, it could be a chunk of code. And what we need to do is identify the individual responsibilities that exist in this piece and then split it at those seams. And during this process, we're looking to narrow the responsibility of each piece, which will, in effect, widen the number of use cases it can be applied to. And I really like the Unix philosophy that each piece should do one thing and do it well. So the question now becomes, how on earth do I find these different boundaries, right? And so when answering this question, there are three things I really like to keep in mind. So again, like we're going to be responsible for one thing. We're going to have narrow responsibility, and each piece should be widely applicable to many use cases. And then each split should reduce the cognitive overhead. So us humans have a working memory of about 4 to 7 things. And if you're me, it's more like 3. And all code has a cognitive cost. So we really need to make sure that the code we write fits within our cognitive budget. So the first thing we're going to look for are pieces that we can reuse. And before we go any further, we need to talk about DRY. So I got a beef to pick with DRY. And I'm sure it's probably one of the first acronyms that came to mind for a lot of us just right now. And DRY stands for Don't Repeat Yourself. And so often when people think of DRY, I think that they interpret it as sharing code that looks the same. But things that look the same are not necessarily logically the same. So the purpose of DRY isn't to reduce your bundle size. It's to avoid redundant logic and therefore redundant bugs. So if you dry something that just looks the same, you're likely going to need to undry them later. So we can take these two forms as an example. We have a registration form and a profile form. And at first glance, they do look pretty similar. They support the same inputs and they just really have a different submit handler. So you think, why not? Why not combine them and save ourselves some duplication? So you abstract these into a new customer form component, and then you leverage it in your two different features, and everything is fine for a little bit. But then something happens. Like typically product will come and say, okay, well, on the profile form, we don't want people to be able to change their username. So we want to disable that field. So now you either have to update your customer form to handle this use case, or you need to go back and spend the time undrying things that should really never have been dried in the first place. So this really does not score very well on our scorecard. The responsibility is quite narrow. You can't really apply it widely. And because we have intertwined concerns in our component, this leads to a higher cognitive overhead. This was not the time to dry. So let's say we have these couple of utility functions, and they're both responsible for a single thing, formatting a specific string. So however, I would say that these are so narrow that they can't actually be widely applied. And while they seem logically distinct, they're actually really similar, right? They're really just formatting strings. So what we could do is this. So don't worry too much about what that parse URI function is doing. What we're interested in is how its API has changed. So now we have a single function that accepts a template string and then just uses regular expressions to inject values into the template. And if you don't like having those magic strings floating around, you can always abstract them away into a meaningful collection or something like that. So now we have our template and our arguments, they're just passed into this one function. And what I really like about this is that I only need to test one thing, and I can apply this behavior to a whole bunch of different use cases. And this is probably one of those functions I just carry around in my back pocket and I bring it out at every single project. I have really gotten a whole lot of mileage out of this one function. So call me biased, but I think that this is a ton of reuse. I think it does one thing and it does it well. It can be applied widely and it's very simple to understand. All right, so when separating and drawing boundaries, another thing we can look out for is separate concerns. So remember, we want to do one thing and do it well. So if you find yourself doing multiple things, it might make sense to split stuff up. Like in this example. So this is just a simple order processor function. It returns a scoped method that just accepts creates a receipt and then emails it. But I'm no mathematician, but I'm pretty sure that's two things. So it's generating a receipt, it's sending email notifications, and this makes it difficult to test the order processor without sending emails, and it's also difficult to test what notifications are going to be sent. So instead of handling notification concerns within the order processor itself, we could do something like this, where we pass in different notifier transports as arguments. So the order processor doesn't need to know anything about how it's being sent. It can just call whatever method we're passing in. And so this feels pretty good. We can now test different notification methods in isolation. We've narrowed the responsibility of order processor, and in doing so, we've widened its applicability. All the while, we're keeping the mental overhead low. So this is a much better separation of concerns. And so there's something in this example that I'd really like to call out. And that's when you identify something that warrants being split out, you don't just have this new surface area, you also have this surface area. So it's just as important that the piece you abstract away be reusable, and it's equally important that the piece you abstracted from be compatible with different implementations of that thing you just abstracted away. Okay. Another thing to look out for is noise. So I like to think of this as a signal to noise ratio, kind of like a radio. So when you're not tuned in quite right, when you're not on the right frequency, there's a lot of noise and it's much harder to hear the music. And it's really the same thing with code. The noisier it is, the harder it is to pick out what's important. So in other words, noisier code has a higher cognitive debt. So when you're writing code, it's important that you ask yourself, what is important? What do I really care about when I'm reading this chunk of code? And anything that's not important can be considered noise and can likely be abstracted away. So we'll take this code as an example. This is a React component that accepts a couple of props and just returns some JSX. And right away, there's a whole lot of noise here. And instead of seeing like front and center the markup I'm actually interested in, I'm just bombarded with a bunch of data manipulation. So this is very noisy and it has a high cognitive load. It takes a lot of parsing to figure out what HTML structure it will generate. And we can greatly reduce the cognitive cost here by simply abstracting that data logic out of our JSX and housing it in like a reusable hook or a utility function. And in doing so, we've widened the applicability of the dashboard component itself. Because remember, there are two surfaces for reuse here. There's the surface that the dashboard expects and the surface of the abstraction. So this means we can easily replace the display logic in the future by simply switching out that use ledger data for a different hook. It just needs to return the same format. Now, without all of that noise, the signal is much stronger and it takes a lot less cognitive effort to understand what the component's template's going to be. So we've already widened the applicability of the dashboard component. All right, so this is an example that caused me some very real world grief not too long ago. So basically what I was doing is I was trying to chase down an issue with our auth. And it all started here. So I've truncated a lot of this just for readability, but this is just an Next.js server action. And it gets permitted resources by calling this function determine permitted resources for entity, which in turn calls fetch group items, which then calls fetch group items summary map, which calls extract group provider from item name, which calls parse item route, which calls build item route, which calls as item route, which then finally returns an array of strings. So I don't, like, what was I even looking for again? Like, that was easily, what, 8 things that I just went through? And I don't remember where I started. I don't remember what I was looking for, and I certainly don't know how I got here. So while each function had a narrow responsibility and maybe they could be widely applied, it really doesn't matter because my cognitive capacity maxed out a long time ago. So this is proof that abstracting things away is not always better, which brings me to my next point. If you don't need to, don't. Never abstract for the sake of abstraction. Only abstract when you need to. So it's always important to ask yourself, do I need to reuse this? Do I need to test this? Is the current responsibility too big? And if it isn't, just leave it, right? Don't start abstracting stuff away before you need to, because if you start making assumptions on what abstractions you need to make, you're going to abstract the wrong thing. So it's always important to remember your cognitive budget and spend it wisely. Okay, so that's step one, splitting responsibilities. Our next step is to strengthen them. So we have a bunch of these, like we have all these small pieces and they are all doing one thing. And now we need to make sure that they're doing it well. So we want to strengthen each piece so that it can accommodate more use cases through robust and meaningful APIs. However, we don't want to expand its responsibility. We only want to make its responsibility more applicable. So we can take this hook as an example. It's just a simple use intersection hook. It's responsible for registering and attaching an intersection observer. It triggers a re-render when the object's visibility changes, and it just returns a single Boolean is intersecting. So there's like nothing inherently wrong with this, but it is lossy. So there's a lot of additional information in the intersection that we just aren't exposing. And that limits the number of places that we can use our hook. So we can make this better. And this is like a really easy fix. Like instead of arbitrarily limiting the amount of information we're exposing, we just return the entire intersection object. So we still have a really narrow responsibility, but we can now apply the hook to many more use cases. So this isn't a more complex API, it's just a less presumptuous one. Okay, let's take a look at buttons. I'm pretty sure we've all written a component, a button component like this at some point. It just returns a single button element and just applies some custom styling. But even this is quite limiting. Like for example, we can't pass a valid child as label because our API enforces a string. We can't bind to other event handlers because we haven't exposed them. And we can't pass in any otherwise valid HTML attributes. So while this is quite narrow, it doesn't really lend itself to great reuse because of its limited API. To make this more widely applicable, we can just open the API to accept all HTML button attributes. And then we just pass them to the underlying button through prop spreading. So like by opening up our prop API, we allow for a very wide number of use cases, and we got this for free. Like not only was it free, it's also fewer lines of code, and that always feels nice. Okay, so our next and final step is to connect responsibilities. So we have our collection of single responsibilities. They all have robust APIs that make them highly applicable. Now we just need to connect them together. And there are so many ways that you can do this. But I'm just going to touch on some of the React patterns that I find most common and the ones that I like to use. So this is probably the most common way to compose things in React. You have a component and then you just Mamushka nest another component inside of it. This works a whole lot of the time. It's narrow, it can be applied widely, it's easy to understand, and this is currently serving the needs just fine, and it's doing it well. But this is also a method of composition that's quite strict. So we'll take this a step further. Like maybe we need some of those badges to be blue. So our current API really doesn't give us that much flexibility. It just accepts like a badge true or false. There's no way to customize it. So one common way to accommodate this is through prop drilling, where you accept the props of a nested component and then just pass them down. And like this just has a bit of a smell to it. It does get the job done, but it's not super elegant. We've done work, but it's maybe not the smartest work we could have done. So, and this brings me to a pattern that I use and I reach for all the time. So instead of assuming what the badge should be and just passing those props downwards, we're now accepting a React node as badge instead. And so this allows the parent to decide what element should be rendered in that slot. And this, again, gives us a whole lot of flexibility for free. We can make the badge a different color. We can render a completely different component. And we've opened ourselves up to lots of additional use cases. But let's keep going. Maybe we want the avatar to link to the user page. Maybe we want it to open a context menu. And we could use that same nesting approach here too, where we just kind of wrap each avatar instance inside a specific component. But come on, where's the style in that? We're going for points. So this is a pattern I can rarely resist. And it's polymorphism. Now, before I get tarred and feathered, I know that polymorphism has a bit of a bad rep, especially in compiled languages, but in React, it can actually be a very powerful pattern. And so essentially what polymorphism allows us to do is to apply the presentation logic of one component onto the behavior of another. So in this case, we're applying the behavior of an anchor or a button element to the presentation of avatar. So our avatar maintains a narrow responsibility, but it's also much more widely applicable and it's still super easy to understand. Okay, so one last thing. Maybe you find yourself having to retrieve user information and then map it onto avatar props. So this example is fine, but this could get mighty annoying if you're repeating it a lot. And it also opens you up to redundant bugs. So like if the use user ever changes, you're set up for a lot of widespread updates. So this is actually a good time to dry and move some of this into a separate adapter, which we can do kind of like this. So we've moved that adapter logic into this specialized hook that just retrieves our user data and then maps it onto avatar props. So all we need to do is call the hook and then spread the return value onto our avatar component. So this keeps our adapter logic centralized. It's easy for us to write new adapters for different data sources in the future. We keep the adapter logic out of our templates, and it's easily testable, safely tucked away to the side. But we can also look at this from like the inside out. So we'll take this video playback as an example. You can see here that we have two distinct video behaviors. There's one that's supporting autoplay and another for playlist behavior. So currently we have this single video component that's serving both, but this results in a bunch of nested checks to customize behavior based on mode. This is difficult to read and it makes it hard to understand what any single mode actually does. And because there's a bunch of concerns all muddied together, you're not going to be able to confidently update this component. You'll always be worried about breaking another mode's functionality. So this is not a narrow responsibility. It can't be widely applied. And because you have all of those concerns, just like mix and matched, you're not going to be able to confidently update this component. You're always at risk of breaking some functionality. So instead, we can kind of take that same pattern we used for the avatar component. So we capture the specialized logic inside these behavioral hooks, and each of these hooks just return the prop API of the video component, which we can pass into the video component itself. So our responsibilities are narrow. We have wide applicability. It's easy to add new behaviors and modify existing ones without breaking others. They're easy to test in isolation, and this is a much lower cognitive load. So that was a lot of code examples. So I'd like to just quickly recap with like why compose software? And first and foremost, it's for improved readability. I always say that reading code is harder than writing code, and high cognitive cost makes code harder to read. Remember, like we only have about 4 to 7 things worth of working memory. And so well-composed code is going to fit within your cognitive budget. So you can have noisy code where there's not enough abstraction, which buries the signal and makes it harder to find what you want. Or you can have foggy code, which has too much abstraction, which makes it really easy to get lost. And at the end of the day, all code is going to have a cognitive cost, so it's important that you make sure you're spending your budget wisely. Another reason to compose is that I would say that properly composed code will result in less code. And that's because we've broken pieces down into single responsibilities and we've focused on exposing robust APIs, which means that they can be widely applied. So while you're more likely to have more code at the start of a project, you should see the reuse kick in as you start to build more and more features. And because you have less code, you have less surface area for bugs to hide in, which means you spend less time debugging and bug fixing. You also have a richer library of code to draw on, meaning that you have to do less in order to support new features and the work gets done faster. And also, because your code base is properly split up, it's easier for more developers to work alongside each other, so you have a better opportunity for concurrent work. A code base that leverages composition poorly is going to accumulate more code in the long run, meaning it will suffer from slow velocity earlier than a slimmer code base would. But Sarah, it's 2026, come on. What about AI? Surely those graphs will look a lot different with AI being able to generate code so quickly. And you know what? You're absolutely right. They do look different, but not in a good way. So sure, AI is going to save you time at the beginning, but AI also easily generates like 150% more code than you need. So that's like 60% of all of that code doesn't need to be there. And even worse, the more code there is, the more context you need to load, the more likely the AI is going to hallucinate, the more tokens it's going to eat, the longer it's going to take to debug or get anything done. And so I would argue that it's even more important to think about these things when you're relying on AI agents. So if you compose poorly, you're going to accrue cognitive debt. And when you have a high cognitive debt, it becomes difficult to work within the code base and the longer it takes to get things done. It also means your development team is going to be confused, and confused developers write bugs. So in closing, you're already doing it, so let's do it well. And that's all I got. Thank you everyone so much for joining.
That was fantastic, Sarah. Thank you so much. Wow, we covered a ton. I will remind the group that the Q&A is open. I have a couple here that I'll throw in your general direction, Sarah.
Let's go.
Maybe I'll start with a personal one. You talked a lot about the different types, the different ways to achieve composition. Which one do you like the most? And again, this can be entirely Sarah's point of view.
Yes, I think this entire presentation was largely Sarah's point of view.
I love it. Thank you.
Here, oh my gosh, I have so many slides. The one that I like the most is probably this one. I kind of just go to this pattern by default because it really just gives you, it just like opens the possibilities of what a component is going to be able to do. And it really does just make it easier to read. So this is the one that I find myself grabbing for even before I technically need it, which I know is against one of my rules, but I don't know. It's true love, man. You can't get in the way of love.
There you go. Never get in the way of love. That's great advice. If nothing else, we take away from today. I have another one, and again, it wouldn't be 2026 without something AI. You mentioned something about good code composition and let's call it token management. Can you give me an example or how you'd like to talk a little like when you're coaching your team around, good code composition and keeping, token economics in mind, what advice could you give?
I think really what makes code easy for humans to reason about also makes it more efficient for AI agents. So I don't have AI figured out. I'm not going to pretend.
I don't think anyone does yet. I
No,
mean,
I
there's
don't
lots of
think,
people who will say they do, but
and they just want to sell you something or they're lying. But I don't really have that figured out yet. So I just kind of focus on making sure that the code that I write is something I understand and that I can reason about so that when the AI starts to fall down, or if I run out of tokens, like that awful time where you have like you've reached like your token limit for the window, I can still be effective in my code base. And I think that's really important.
No, I would agree. That's great advice. Last question that I have, and then again, I will throw to the floor if anyone has any more coming in. But you've had an amazing career here at Red Space. You were an accidental developer, I think is what you told me in the
Yeah.
pre-interview, which I love. What advice would you give to someone who is just starting their career now? Like they are just either just graduating from school or they're just getting on the ramp to having a career in development. What advice would you give?
Probably the most important piece of advice is just start building. Start building. Find problems in your life that you want to solve and then solve them. Put it up on GitHub. Talk about it in a blog post. Post it on LinkedIn. Start just like accumulating a portfolio of problems that you've solved. And that speaks volumes to other developers.
I love it. That's
Yeah.
great advice. So, layering onto that, and again, you have told me that you are a self-confessed nerd. Where do you find where do you hang out? Where do you get your inspiration or ideas, or where do you find your community online?
Ooh, you know what? I'm like a largely analog girl. I find most of my connections like probably in person. And a lot of the tech that I write is to help people close to me solve problems. Um, so I don't really have an online community.
Oh, all right.
I think I got stuck in the scroll. I think we've all got stuck in the scroll, and so I've had to kind of like separate myself from some of that stuff a little bit. So
Totally get
I'm
it.
analog.
All right.
You can find me at the local brew pub after work with a cold pint. That's where you'll find me.
Depending on where people are joining us from, that may be harder to find. So, if there's nothing else from the audience, I am going to bring us in for a landing. Sarah, I want to thank you very much for everything. Amazing job. No surprise. Lots of pearls of wisdom there. Thank you very much. I will remind everyone that this is part of a series of webinars that Red Space is doing. I'm excited to announce our next webinar is coming up on June 24th with Jonathan Terry, who is our QA lead here. Stay tuned for more details on that. We will be pushing that out very soon. But with that, I will say that this brings us to an end. Thank you again, Sarah. And for everyone who joined us, either live or watching this as recording, thank you again. If you have any questions, do not hesitate to reach out. All the best.
Thanks, everyone.